Welcome back to the AI Foundation Learning, where we dive deep into the world of artificial intelligence. Today we're exploring the fascinating topic of vector databases in generative AI. Whether you're a beginner or a seasoned professional, this video will give you a comprehensive understanding of how vector databases can revolutionize your AI applications. So, let's get started. Let's start by setting the context. Generative AI is powered by foundation models, also known as FMs. These are pre-trained on vast amounts of data and include large language models, or LLMs, like OpenAI's GPT-3, Claude from Anthropic, and Llama from Meta. These models are accessible through various platforms that offer APIs for building generative AI applications. Despite their power, LLMs have some limitations. They have a knowledge cutoff point, meaning they only know data up to the time they were trained. They can also hallucinate, providing incorrect but confident responses. Moreover, they lack access to external data sources, which can be crucial for domain-specific applications. This is where vector databases come into play. But what exactly is a vector? In simple terms, vectors are numerical representations of text, capturing the semantic meaning. To create a vector, you pass text through an embedding model, which outputs an array of floating point numbers. These vectors are then used for relevancy or context-based searches. There are two main categories of vector databases. First, we have vector data type support within existing databases like PostgreSQL, Redis, OpenSearch, MongoDB, and Cassandra. The second category consists of specialized vector databases like Pinecone, Weaviate, Milvus, Qidrant, and ChromaDB. These databases are designed specifically for handling vector data and are evolving rapidly. Let's explore how vector databases fit into generative AI solutions. Imagine you have domain-specific data that you need to use for an AI application. You start by splitting this data into chunks and passing them through an embedding model to create vectors. These vectors are then stored in a vector database. When a user query comes in, it's converted into a vector, and a semantic search retrieves the most relevant results. Finally, these results are combined with the query to provide a more accurate response. A popular technique leveraging vector databases is Retrieval Augmented Generation, or RAG. RAG involves three key steps. First, data ingestion, where source data is chunked, embedded, and stored in the vector database. Second, the end-user application processes the user's query, converts it into a vector, and performs a semantic search. Third, the retrieved results are combined with the original query and sent to a large language model to generate a precise response. Let's walk through a simple demonstration of using a vector database in a generative AI application. First, data preparation. Start by collecting your domain-specific data. This could be text documents, PDFs, or any other relevant information. Next, embedding. Use an embedding model to convert your text data into vectors. Popular embedding models include BERT, sentence transformers, and others. Then, storage. Store these vectors in a vector database like Pinecone, Weaviate, or Milvus. These databases are optimized for handling and querying vector data. Now, query processing. When a user inputs a query, convert this query into a vector using the same embedding model. After that, semantic search. Perform a semantic search in the vector database to find the most relevant vectors corresponding to the user query. Finally, response generation. Combine the retrieved results with the user query and send this combined input to a large language model to generate a precise and context-aware response. By following these steps, you can leverage vector databases to enhance the capabilities of your generative AI applications. Let's now discuss the key benefits of using vector databases in generative AI. Vector databases offer numerous advantages that can significantly impact your AI applications. Here are some key benefits. 1. Enhanced accuracy. They improve the relevance and accuracy of AI responses by leveraging semantic search capabilities. 2. Scalability. Vector databases are designed to efficiently handle large data sets, making them scalable for extensive applications. 3. Speed. They provide faster search and retrieval operations compared to traditional databases. And 4. Flexibility. Vector databases are flexible and can be applied to various domains and data types. In conclusion, vector databases are a game changer for overcoming the limitations of LLMs in generative AI applications. They enable more accurate and context-aware responses, making your AI solutions smarter and more effective. Looking ahead, the future trends of vector databases are incredibly promising. We can expect advancements in their capabilities, more sophisticated search algorithms, and broader applications across various industries. That's it for today's deep dive into vector databases in generative AI. I hope you found this video insightful and now have a better understanding of how these databases work and their potential benefits. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more AI-related content. Thanks for watching, and see you in the next video.